Hello everybody, I start second lecture of the medical chemistry and I continue with atomic mass. As you know, atoms have a very small mass. For example, hydrogen with one proton and one electron has a mass around 1.6 times 10 power minus 27 kilograms. It's equal the mass of one proton and one electron. Because electron is very small, we can say it's almost equal the mass of one proton also. Okay, for this reason we use methods, for example, non-SI unit. For the mass we use the relative scale. When we use a U is the unit, is the unified atom mass unit, or Dalton we can use also. 1 unit is equal 1/12 of the mass of the carbon-12 isotope. Because it is this very easy, and because the 1/12 of mass of the carbon-12 exactly is the 1. As you see here, carbon-12 has 6 proton and 6 neutron, and the isotope mass is exactly 12. And the mass is almost 98% of the nature we can find, but other carbons 13 and 14 with other isotopes has more neutrons, has not exact mass. For example, carbon 13 has a 13.00335, or carbon 14 is around 14.00324, and also the mass in the amount in the nature is very low, and the average of the carbon mass it is 12.0107 because of different type of the isotope. As you see here, carbon is in the group 4. It has atomic number is 6, and it is we can use the carbon-12 for the unit of the mass in the periodic table. And the second is the molar concept. Molar concept, it started in the 2018 and IUPAC journal Pure and Applied Chemistry. There is a new definition. The mole symbol mole we can see in the chemistry with the symbol mole. In the SI unit is the substance is equal 1 mole contain 9.022 almost times 10 power 23 elementary entities. This number is the fixed numerical value for the Avogadro constant we can show with Avogadro number, because when expressed in the mole power -1 or 1 over mole, and is called Avogadro number. And in the unit system we can show mole with the symbol of N in the formula, amount of substance, and the unit is the mole, and the symbol can be mole. Avogadro number also we use also 6.022 times 10 power 23. And the molar mass of the subunit substance is the mass of the 1 mole of the substance unit gram per mole. For example, I explain for you for some element or some. For example, we have hydrogen. Atomic mass is the 1 gram per mole. Oxygen is 16 gram per mole. Okay, then water molecular mass is the 16 plus 2 is 18 gram per mole. Now we can say 1 mole of water has 6.022 times 10 power 23 molecule of water, because as you see the unit, because if we have a molecule of water here, we have a molecule of water. Or we can say 1 mole of water, because it has every water has 3 atoms, then we can multiply 3 times 6.022 multiply 10 power 23 atoms. It's very easy. In this system, we can use this system for the find amount of the mole, and it is very easy. And when we find the mole, we can also find the relation between mole and the mass. For example, I write in the next page. For example, again, I start with the CH4 is the methane. Okay, as you see, methane, first I write here atomic mass of carbon. Okay, relative atomic mass is a 12. Hydrogen is a 1. Then CH4 is the 12 plus 4 is the 16 gram per mole. Molecular relative mass is the 16 gram per mole. Now I can say 1 mole methane has a 6.022 multiplied 10 power 23 molecule of methane. And again, 1 mole of methane has, because it has a 4 atom, 4 times 6.022 times 23 atoms. Or we can write again 3 times. 1 mole of methane has a 3 times. No, it is for hydrogen, atom of hydrogen, excuse me. And if we multiply 5 times 6.022 times 10 power 23, all of atoms. Also, we can say 16 gram of methane, because 1 mole is the 16 gram. If you see here, 1 mole is the 16 gram of methane. Has, we can write again these, I can copy here. $16 grams of methane, we have a 6.022 multiplied 10 power 23 molecule of methane. Also, we can copy here again the same for this system. If you see here, system is the same, and we can know about this. We can repeat again. Copy and here paste. Again the same, 16 gram of the methane, and again it has the same 4 times 6.022 times 10 power 23 atom of hydrogen, and 5 times 6.022 multiplied 10 power 23 at all of atoms. Model of atom, we studied last lecture about 2 models of atoms, which it is the Pauli model also, and we have a Planetary model for the studying of electron and the nucleus, is where we studied in the last lecture. Now we go problem with the Rutherford models. As you see here, the first problem is the stability of atoms, okay, because we don't have same stability for every atom, and also difference in the emission spectrum of element, because in the Rutherford method, as you see here, we have, for example, 2 different elements, has a 2 different emission spectroscopy, and it can be not explain. We cannot explain with the Rutherford's models. An emission spectroscopy of atom is made of the bright line in the dark background. If you see the background, and we have an emission of the light in the background, the line form regular pattern. As you see, depend for the atomic mass and the number of electron and atomic number. If you see here, the spectrum, emission spectrum different. Because of this reason, the quantum mechanism start. Quantum mechanism is non-classical because we know the Newton physics is classical, and it is. But for the quantum theory, it's non-classical. The first scientist also speak about is the Planck. Planck, he mentioned electromagnetic energy is emitted or absorbed in the discrete amount in the quantized form, and it is very important. He find the energy is equal Planck constant multiply frequency. It's very important. In this case, we can calculate the energy of the atom with the Planck constant and frequency, and the Planck constant is a constant number, which is here 2 seconds. And we use frequency. Also, we can find frequency with other model of physics from the wavelengths and speed of light. The other one is the Bohr models. He mentioned there is two systems. One is the energy level postulate, and the electron in the atom have only specific energy value, which is called energy level of the electron in the atom. But then we have to see, now we know about the energy level in the atom. Depending on the position of the electron, we can have a different energy level. Transition between energy level, okay, then electron undergo the transmission from one energy level to another one. The difference between the energy level also we can find with the Planck formula, which can be emitted or absorbed. Is very important. The different energy levels can helps to find how much energy can be converted to the emission or absorption. It is very important. For example, here, emission spectroscopy of hydrogen, if you compare here the level of the here, we have several layers. If you start here, it is the first shell, is the M1, and the second shell, and between these two, third shell and fourth shell energy levels is different. And it has orbital energy. As you see here, we have a different layer. The first layer is Lyman, the second one Balmer, and the third one is Passion. And it's very important we know about the energy level of orbital. If you see here, we can also see here Lyman, the first one, and the Balmer is the second, and the Passion is the third one. And about the Lyman, in the Lyman series, we use a hydrogen spectral series of the transition and the resulting ultraviolet emission line of the hydrogen as the electron goes from the second layer to the first layer. And it starts the principle of the quantum number. Okay. And we continue about the quantum mechanism, and other scientists, de Broglie, spoke about the dual nature of the electron. Electron has the electron wave nature of electron is very important, and in the quantum mechanism, wave function can be applied for the property of electron. The most important things in the physics, in the quantum mechanism, Schrödinger equation and Heisenberg, two scientists, they spoke about the position and the impulse of electron cannot be determined precisely. Then we can say no exact place for the electron we can find in the atom, because we can just predicate the position. And because of this, in the whole, we can find the quantum mechanism principle, and each electron described by 4 quantum number. Quantum number, it is start with 4 quantum number. Okay, I can write here principal quantum number, angular quantum number, which show with L, magnetic quantum number, and spin quantum number. We can really see about this. It shows the mainly energy and the probability of the finding of electron. And in the end, we can say it's atomic orbital. It's the region of the space where there is a high probability of the finding the electron. It is one of the important things in this part. The first one is the principal quantum number, which shows by n. N is the natural number which starts with a 1, 2, 3, 4. For every number we can use the alphabet name is the K. 1 is the K, 2 is L, 3 is M, 4 is N. It shows shells. Okay, so shells which around the nucleus in the atom. Okay, N shows size of orbital and energy of electron. It's very important. But angular momentum or azimuthal quantum number, or we can angular momentum quantum number, we can show by L. It starts with a 0, 1, 2, 3, and the relation is the L equal m minus 1. If we principal quantum number minus 1 is angular momentum number, it is a subshell. 0 is the S, 1 is the P, 2 is D, and 3 is F. They are orbitals, okay, which we study about S orbital, P orbital, D, and F orbital. It shows shape of orbital. For example, S is the circular, and also energy of the electron. We can show it. Then we can see shape of orbital and the energy is very important. We know about this, and now we understand in these two quantum number, at least the size of orbital, shape of orbital, and energy. And for example, P is the pair of the lobe of the which has the opposite side of the nucleus. Okay, also we can say somewhat dumbbell shape, okay, like this dumbbell shape, or because it has this, we see study now. And as you see here, it's spherical, and if you see it like a dumbbell shape in the 3 axes, px, py, pz, but d and if it's complicated, d in the xy axis, xz, yz, x2 minus y2, and z2, it is if you see, S has 1 orbital, P has a 3, and D has a 5, and F has a 7. And the magnetic quantum number we show with the ML. Okay, it is from the minus L until positive L, and it shows the orientation or direction of orbital in this space, in which axis it is, in the x-axis or YZ, or like I showed you in the last page. The energy of the electron does not depend on it, because in this case we just see p orbital, the same energy, but it's in a different direction. Spin quantum number we show with the MS. MS we have just two possibility, minus half and positive half, because possible orientation of electron can be positive direction or negative direction. For example, I start quantum number here. I said if the n is 1 is the K shell, okay? M minus 1 is the L. L equal minus 1 we can find here. 0 is the S orbital. S orbital is the circular, spherical. And the ML just is the 0, and we have just 1 orbital. And we have 2 possibly electron here, generate the maximum 2 electron. It can be 1 or 2 electron, maximum 2. And L shape has n equal 2. Again, L equal m minus 1. 1 minus 1 it is a 0. 2 minus 1 is 1. And because 1 also we have to go to 0 also, we have 2 shape, 0 and 1. And the 0 we wrote in the last one, it is the S. And for the ML, for the P, we can write from minus 1 to the plus 1. And it has a 3 orbital. Then I can write in the 2s, we have a 1 2s and 1 2p. 2 electron can be in S. And the 6 electron maximum we can have in the P. And then in the 2 we can maximum have the 8 electron. Then we can say in the K shell we have a maximum 2 electron. In the L shell we can have the maximum 8 electron. In the M shell, n is the 3, n minus 1, it is 2. The last one in the subshell, we can have the 2. And again, we can have the s orbital. We study the first one, maximum 2 electron. Second one, p, we studied before, the maximum 6 electron. Now, because of we found the other L is the plus 2. From the minus 2 plus 2, we can find the d orbital is the subshell is the d orbital. It's from the minus 2 plus 2. It is a 5 orbital, and we can have a maximum 10 electron. Okay, altogether is 18 electron. Okay, and I didn't write n. I write n here also. Okay, for n equal n. N is the 4. Then we can find L equal n minus 1 is the 4 minus 1 is the 3. From the minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3. It is ML angle, okay, magnetic quantum number. It has a 7, and we have a before, okay, it is the 4, we can write. Okay, if you see here, until here we have orbital 3, but here we have first one is the 4s, maximum 2 electron, 4p, like last page I showed, maximum 6 electron, 4d, 5 orbital, maximum 10 electron, and 4f, because it is a 7 orbital, we can have a 1, 2, 3, 4, 5, 6, 7, maximum 14 electron. And altogether 14, 24, 32 electron we can find maximum in the principal quantum number with 4. As you see here in the quantum, we have a subshell. A subshell, it is a spherical, and it has a L is equal 0, ML is equal 0. It is one orbital is spherical, and we have P. L is equal 1, is n equal 1, n equal 2, n equal 3, n equal 4. Again, n minus 1 is the L, it is here 1, and from minus 1 to 1 we have a 3 orbital, and d 3 minus 1 is the 2, from minus 2 to plus 2 we have 5 orbital, and f orbital for minus 1 is 3, from minus 3 to positive 3 is 7 orbital, and okay, it is a maximum 2 electron, maximum 6 electron, maximum 10 electron. In every orbital we can have maximum 2 electron, and 14 electron maximum. We can show here in this type of shape, and the electron we can, with the spinning quantum number, we can show up, one, and down hole. Okay, now we understand about the rule, but there is a very important rule in the electron structure of atom. It is the building up principle. The electron fill up the orbital in increasing order of energy. Then usually we go from the first shell to the subshell to the second, or cell, and also shell from the 1 to 2. But here there is a building of principle rule is very important. He mentioned first is no problem. Until D we go with the same rule, 1s, 2s, 2p, 3s, 3p, until here no problem. But here we don't go to D, because energy D first 4s, then go to the 3ds. 3ds is exception between the filling, first the 4s filling, then 3d. Again 4p is no problem. In the 5 group is also we have 5s, 4d, 5p, 6s, and like we continue with this situation. And it's very important, the filling of a d orbital and f orbital is always after s orbital, okay? And it is just the place changes here, you see? The first is the 4s filling, then 3d. The other is Pauli exclusion principle. He said we cannot find any atom in any electron in every atom, every 2 electrons we cannot find in the atom has the same 4 quantum number. It's impossible. At least one of the quantum number must be different in every atom. Okay? Hund says very important. When we start filling of the orbital, for example, its atomic number is 7, we have a 7 electron. If we have a 7 electron, if you see first we fill in the 1s 2 times, okay, second is 2 times, we have remains 3. We can fill just first with the same direction, okay, we cannot say it is okay here, we can see it is a 2, it is 1 remain here, no, it's wrong. We can just first fill the same spin, same direction first, and if we go down, then we can say, for example, I write oxygen, okay, here, oxygen is 8, 1s2, first layer, 2s2, 2p4, okay, for 1s2 it is a 2 electron, 1 up, 1 down, no problem, 2s2, 2 electron, again, for the 2p4, we have 4 electrons, first same direction 3 times, then come back the first one is a 2. I cannot write like this 4 times, go up, go down, go up, go down, is a 9, it's absolutely wrong. And we will study later about it is a ground state, sometimes happen to excite state, sometimes we have free orbital and the electron can jump from the subshell to the other subshell, and it's very important. And now I have summary here about combination of the quantum, but I explained it for you. Principal quantum number, KL, M, N, and L is equal, angular is the principal -1, 0, 0, 1, 0, 1, 2, 0, 1, 2, 3. ML start from the -L to +L is here is just a 0. Here is just a 0 as -1 to the +1. Again, we have a same here and same here. Okay, the number because the name is the number of the principal quantum number is n with it is 1s, 2s, and 3s, 3p, 3d, and 4s, 4p, 4d, 4f. Number for electron is 1, it is a 3 for the p, d5, and the f is the 7. Okay, number of electrons we can see here. The number of orbital here is just one. We have 1 orbital, 4 orbital, 9 orbital, and 6 orbital. If we multiply 2, all of them will be number of the maximum electron. For example, maximum of electron we can find here. Okay, the first shell we have a 2, second shell is 8, third shell is 18, and fourth shell is the 14, and this here. And in the next lecture I will start with the periodic table. I hope it will be good, and see you next lecture, and have a good time.